Hello everyone. In this lesson, we are going to solve real-world application problems using the derivative to find the rate of change. In this example, we have a car heading west and another car heading north from south. Eventually, they meet at a point. It's the intersection I. So the car heading north is traveling at 60 miles per hour. And let's call this car B. And car A heading west is traveling at 50 miles per hour. And they will meet at the intersection I. So the distance between these two cars at any time, given any time, so here's my car B, and here's my car A. Car A is heading west at any time t. The distance between these two cars is going to be distance c. C is the distance between car B heading north and car A. Let's label car A here. That's car A is heading west. We want to find out at what rate are the cars approaching each other. So that would be D, C, D, T. And that's what we want to find out. So let's write down here. We want D, C, D, T when A is 0.3 miles from the intersection and B is 0.4 miles from the intersection. This is what we want. Now, we are at the intersection. That would make a right corner, so we have a right triangle. In the right triangle, we have A squared plus B squared equals C squared. And that's the formula that we want. Keep in mind, in related rate problems, we always have given. So let's write that down. This is given. And the given is the information that we get from the problem, plus a formula describing the picture. So the formula here is going to be A squared plus B squared equals C squared. And this is what we want to solve. So we're going to go over here and say work. And work is going to be taking the derivative with respect to time. So we always have a formula describing the picture. Now we need to take d dt, both sides, to find the rate of change with respect to time, or the rate at which the two cars approaching each other. So d dt of c squared. So with respect to time, the derivative of a squared is going to be 2a times dA dt, the derivative of a, plus 2b times dB dt, that is the derivative of b, and 2c times dC dt. Now simplify the equation. I have, dividing both sides by 2, I have a times dA dt plus b times dB dt equals c times dC dt. We have a and b. Now we need to go find c. We know that a squared plus b squared equals c squared. So we have 0.3 squared plus 0.4 squared equals c squared. 0.9 plus 0.16 equals c squared. C equals 0.5. And it is a Pythagorean triple, 3, 4, 5, or 0.3, 0.4, 0.5. Now we substitute in 0.3 for A, 3 miles. dA dt is negative 50 because as A approaching to the intersection, the distance is decreasing and the derivative is negative. So it's negative 50 plus B is 0.4 miles times dB dt. And dB dt is negative 60 because as car B approaching the intersection, the distance is decreasing. And when it's decreasing, the derivative is negative. Equals C, which we found, 0.5, times dc dt. So let's go over to the picture one more time and review the concept of negative derivative. When the distance is decreasing as the car approaching to a point of intersection, the derivative is negative. So we must remember the rate of change is negative when the distance is decreasing. Also, A is approaching the intersection heading west, and the distance is getting smaller or decreasing, and its derivative or the rate of change is also negative. So we must write negative 50 miles per hour. Now to work out the math, we will simplify the left-hand side and we get negative 15 plus negative 24 equals 0.5 dc dt. To solve for dc dt, which is the rate at which two cars are approaching each other, we divide both sides by 0.5 and divide this by 0.5. So the rate at which two cars are approaching dc dt will be negative 78 miles per hour. And we check the answer. This makes sense because as two cars getting closer to the intersection, the distance c is getting smaller or decreasing. The derivative or the rate of change is negative. Good luck on your homework, and I will see you in the next video.